Okay, we've hit the parabola section. In this section, there's a lot to learn about the graph of a quadratic function, if it hits the x-axis or not, what's a vertex, things like that. You know, it gets shifted around, and also using it to figure out a max-min solution. So I found myself forced to break this into 3 different videos. And the first one's going to deal with the basic parabola and stretching and reflecting that parabola. Okay, so we need to talk about this. The next section will deal with shifting and the vertex. And then finally, we'll take care of a quick way to graph a parabola and how to solve a max-min problem. Okay, let's do this. So the basic parabola, if you've never done a parabola before, you take your basic parabola, and I usually start students off with y equals x squared, the most fundamental quadratic function of them all. Okay? And I have students go ahead and find a bunch of ordered pairs, and they usually go 0, 1, 2. And in each case, you're squaring. Because that's what the function says to do, right? Take x and square it, and that's y. 0, 1, and 4, right? And you go over here if you want to, and you can start plotting this thing. And 0, you see the ordered pairs right here? We have 0, 0, so we plot that point. 1, 1, okay. And 2, and 1, 2, 3, 4. So there's a bit of a curve to it. Let's connect the dots. Pretend I connected the dots. That is horrible. It's hard to do on this thing. I'll get the hang of it. Okay, and hit that button. But that's only half the battle, is it not? Because those in the know say, yeah, but you didn't plot the negatives. You're right, I didn't. What if we put in -1? Well, that's equal to -1 squared. Do you know what people do? Oh, that's -1. No, it's not. You're supposed to multiply it together. You get a positive. -2, same thing. -2 times -2, +4. Aha! So it's creeping up on this side as well. -1, 1, and -2 and 4. And you are looking at a beautiful, well, a parabola drawn by Weber. Okay? All right. So that's what they basically look like. And you can mess with them by doing stuff like, how about if I multiply x squared by 2? What if I add a number to x squared? What, you know, and we'll talk about that. But this is your basic guy. Okay. I think the next thing I have us do is talk about the anatomy of the parabola. You should know these things. The low point down here, in this case, the very extreme low point, and by the way, parabolas can also open downwards as well. And the low point in that case would be the high point. But this point, that special point, has a name, and what is it? Vertex. We're just borrowing Latin words for all of this. So that's the vertex. The axis of symmetry is the vertical line that passes straight down the middle. Okay, so it's going straight, slicing right through the parabola, and they call that the axis of symmetry. So far in this picture, the vertex is the point 0, 0, and the axis of symmetry is really the y-axis, but we would say x equals 0. Okay, and then the other parts are like the intercepts. That's basically stuff you already know, like the y-intercept, the x-intercepts, if any. If any. And in this picture, it's basically it's the same thing. Where does it run into the x-axis? Where does it run into the y-axis? Okay. Well, in both cases, it's the vertex. That's where it does it. So the y-intercept is 0, 0, and so is the x-intercept. So the basic guy, that's what it looks like. Okay? All right. So all parabolas have this kind of shape to them. What's really cool about parabolas is there's this physical fact that when you have, let me get the right color here. I love this part about it. When you have a perfect parabola, what happens is a light wave or an energy wave would bounce physically to a single point. If you're bouncing this way, it bounces here. If you're hitting here, it bounces there. Everybody focuses on what they call actually the focus of the parabola. That's a different class, but that's really cool. It allows scientists to collect, data from outer space. It allows us to pick up on our direct TV if you want to. You got a paraboloid on top of your roof or whatever. It allows you to cook a side of bacon right there. If you're collecting the sun's rays, it will cook for you. Everything gets focused. Pretty cool thing. All right, so what we're doing is now in this video, what we'll do is talk about what happens if you decide to multiply x squared by a number. Okay, and the only way really to explore this, oh good, I have my video, my coordinates down there. To explore this, if you're really a raw recruit, is simply to go, well, here's x, and in this case, I'll call it f of x, okay. And again, you plot points. 0, 1/2 times 0 squared is still 0. Okay, he's cool. 1, 1/2 times 1 squared is 1 times 1/2 is now we at 1/2. And 2, 1/2 times 2 squared is 1/2 times 4, which is back down to 2 again. And likewise, -1, 1/2. And -2, 2. So what does that do to our curve? Okay. Well, I thought I had a, no, I guess I didn't. It must be a different, I don't know where I did that. You know what, I might have done it in class, I'm not sure. But I had a Desmos where you had the 3 different curves showing up. Okay, I'm having a brain, you know what, I'm not remembering. Okay, so for this particular guy, when we plot the points, we're still at 0, 0. But instead of 1, 1, we're at 1, 1/2. And instead of 2, 4, we're at 2, 2. Okay, it's interesting to compare these two. I can do this, no problem. Okay, typically it's 0, 0, 1, 1, and 2, 4 up here, right? So the original curve, if I put it in lightly, does this number. That's not lightly. And the new curve, let's put them in maybe in this color, is actually widening out a little bit. So the same story on the other side. You've got -1, 1 and -2, 4, and so he typically does this. But when you do this game, it's -1, 1/2 and -2, 2. So the net result, I know where I did that. I did it for Calc 2. I had some nice graphs for them because they have to learn this again, where they have to learn the focus and all that stuff. You guys are just now learning it. Look what the multiplier 1/2 times x squared did. It slowed the growth of y by 1/2. It impeded the growth, and therefore your parabola is wider. What do you think would happen if instead of a 1/2 we put a 2 there? Yeah, it would double the speed, and it would be a narrower parabola. In fact, I think I'm doing that here, and I think I'm attempting to kill 2 birds with 1 stone, because not only are we taking g of x is equal to 2x squared, but we're making it negative to boot. All right, what do you think happens here? And some of you do have a memory of this, maybe from high school. Again, 0, 1, 2, -1, -2 for the heck of it. Let's see what happens. Okay? All right. So 0, -2 times 0 squared is still 0. So you still got that low point, or is it a high point? Look what happens here. -2 times 1 squared, 1 times -2. Now we're at -2. Look at 2. -2 times 2 squared, -2 times 4 is actually -8. And what happens is -2 times -1 squared, you get the same thing, -2, and this guy's -8 to cut to the chase. And then we go to plotting these points. Okay? 0, 0, all right? But look what happens. 1, okay, let's put the original up there for fun. The original guy is 1, 1 and 2, 4, remember. So he's cruising this way and this way. That's the original parabola, right? But this guy is going 0, 0, but then 1, -2, and whoa, watch out. 2 and 1, 2, 3, 4, 5, 6, 7, 8. Sometimes I mark on the wall I've been known to in the classroom. He's way off the charts. Can't do it somewhere with a wall talker. It's above my reach. But then also -1 and -2, and then -2 and way down here. So what is the net effect of putting a multiplier in front of your parabola? Well, it stretches or shrinks it, okay? With the multiplier we had in this case, y is equal to 2x squared, it made it narrower. This one made it wider, a wider parabola. But this one is narrower because of the multiplier. But now here's an important fact for you guys. What was the effect of the negative? See it? It reflects the negative multiplier reflects the parabola. Like you're looking at a very still lake, you see a reflection of the mountains or whatever that reflects the parabola, not the mountain, but the parabola across the x-axis. So instead of everything opening upward over here, the parabola is actually opening downward. So it opens up here, and that's one of the questions. But this one opens down. How can you tell? I can tell you how you can tell. This guy has a negative. This guy doesn't. This guy's going up. This guy's going down. Remember that. Okay, that's it for this video. We'll get a little deeper in the next one. See ya.